Alright guys, so we're going to talk about dividing radicals. There's about kind of 3 different cases, so we're going to talk about different things that you might see. Well, the first thing for case 1 is see if that we can divide everything. So if there's something that we can simplify on the top and the bottom, we're going to do that. So what I mean by that is I can write this as one radical. I can just say that this is the square root of 50x to the third y over 2x y to the fifth. Okay. Now that I did that, I just have that square root, and then I put that fraction over just one fraction instead of having 2 square roots. So now what I'm going to do is I'm going to go ahead and just divide this fraction or simplify it. So I have a 50 on top and a 2 on the bottom. So I know I can divide both of those by 2. So if I divide 50 by 2, I would have 25 over, if I divided that 2 that was on the bottom by 2, I would have 1. Okay? Now if I look at my x's, I have 3 x's on top of the fraction, and I have 1 x on the bottom. So I can take away 1 on top and 1 on the bottom, so I would left with 2 x's, or x squared, on top. Okay. And then I have 1 y on top and 5 on the bottom, so I can take away 1 from the top, from 1 on the bottom, and then I have y to the fourth. Now remember, this is all still under a square root, so I'm going to go ahead and square root both the top and the bottom. So on the top I have 25x squared. Okay, so let's think, if I square rooted 25x squared, okay, well, the square root of 25 is 5. And if I have x squared, I want groups of 2. So how many times does 2 go into 2? Just once. So I have just 1x. Okay, that's going to be on top of the fraction. Okay. Now if I square root the bottom, which is just really y to the fourth, or 1y to the fourth, I think we're looking for groups of 2. So how many times does 2 go into 4? Just twice. So this is going to be y squared on the bottom of the fraction. So we have 5x over y squared. So what's nice about this one is it's really just what we've done in the past. We're just going to simplify our fraction first, then we square root the top, and then we square root the bottom. So if it was a cube root, we would just cube root the top and cube root the bottom. And then 4th root, 5th root, whatever it might be. Now if we take a look at this one, okay, on case 2, we have 2 plus square root of 7 over the square root of 3. Now I don't have everything's under one square root, right? We have this 2 plus the square root of 7. And there's not a number that we can take out of all those, or really can't simplify it. So what we have to do is called rationalize. So when we rationalize, that means that we are getting rid of the square root at the bottom of our division, or on our denominator. Okay? So what we do to do that is we're just going to multiply the top and the bottom by whatever our square root of the bottom is. So since it's just the square root of 3, I'm going to multiply the bottom by the square root of 3 over the top by the square root of 3. Okay. The reason why you do that is we want to get rid of that square root. And you'll see here in a second why that does that. So if I multiply out the top and the bottom, so I'm going to do the bottom first. The square root of 3 times the square root of 3 is the square root of 9. And some of you might be like, well, we know what the square root of 9 is. Yeah, exactly. That's what we want. We'll deal with that here in a second, though. So let's look at our top. Now I'm going to multiply 2 times the square root of 3, which is 2 square root 3. And then we have the square root of 7 times the square root of 3, which is going to be plus the square root of 21. So we just distributed that top out. Okay. So now I'm going to clean this up. Okay. On the top we have 2 square root 3 plus the square root of 21. If I try to break down 21, it's just 7 and 3, and there is no pairs, so we can't simplify that anymore. So I'm just going to leave the top as the 2 square root 3 plus the square root of 21. Now on the bottom, we have the square root of 9. So what can we reduce or simplify the square root of 9 to? Well, the square root of 9 is just 3. Okay. And there's nothing that we can simplify all those by, so our answer is just this. Now, we have 2 square root of 3 plus square root of 21 all over just 3. Now you might say, well, there's a square root of 3, a square root of 21, and a 3. We can divide all of them by 3. Remember, we can only do that if they're all on the outside of the square root or the inside of the square root. So since the bottom is not inside of a square root, we can't divide anything. Now, the last one, we just had one term in the bottom or in the denominator. If we have two terms in the denominator, we need to multiply the top and the bottom by the denominator's conjugate. We talked about a conjugate when we did imaginary numbers. Remember, like if we had 1 plus 2i, its conjugate would be 1 minus 2i. So it's going to be kind of the same concept with that. So if we look at our example, we have 4 plus the square root of 3 over 10 minus the square root of 2. So what we're going to do is we're going to multiply the bottom by the conjugate. So I'm going to do it to the left, but we're going to multiply the bottom by 10 plus the square root of 2. Okay, since it was 10 minus square root of 2. And if we do it to the bottom, we have to do it to the top. So I'm going to multiply the top by 2 plus the square root of 2. So we're kind of multiplying by kind of a fancy one. Okay. So on the top, we're just going to distribute this out kind of like what we did on Friday. So 10 times 4 is 40. 10 times the square root of 3 is positive 10 square root 3. Okay. Now I'm going to do the square root of 2 times 4, which is positive 4 square root 2. And then I'm going to do square root of 2 times the square root of 3, which is positive square root of 6. Okay. Now we're going to do the same concept on the bottom. I'm going to have 10 times 10, which is 100 on the denominator. Then I'm going to do 10 times negative square root of 2, which is going to be minus 10 square root 2. Now I'm going to do this positive square root of 2 times 10, which is positive 10 square root 2. And then I'm going to do the square root of 2 times negative square root of 2, which is negative square root of 4. Okay. Now, our next step is we're just going to go ahead and simplify this or kind of clean it up. Okay, so on the top I have 40 plus 10 square root 3 plus 4 square root 2 plus square root of 6. Square root of 40, or just 40, we can't do anything with. That's done. We can't break down the square root of 3. We can't break down the square root of 2. And if we break down 6, there's no pair. So I can't simplify or combine any like terms on top. So our top is going to just really stay the same. But let's look at our bottom. Okay. If we look at our bottom, we have 100, and then we have negative 10 square root 2 plus 10 square root 2. So negative 10 square root 2 plus 10 square root 2 would just add up to 0. So those kind of cancel each other off. The next thing that I notice is I have a minus square root of 4. Well, we know square root of 4 is just 2, so this is just going to be minus 2. Okay. So now I can combine like terms. So 100 minus 2 is just 98. So I'm going to have 98 at the bottom of my denominator. Now on the top, we're just going to, nothing could simplify or combine on top. So we're going to have 40 plus 10 square root 3 plus 4 square root 2 plus the square root of 6. Okay, all over that 98 that we simplified. Okay, so this one can kind of be a little bit of a lengthier process, but the concept isn't much different than what we did yesterday. It's kind of just like two multiplication problems, and then we just simplify them. So explain what it means to rationalize a denominator, and how do you know which method to use to accomplish this. We talked about rationalize a denominator. It just means to get rid of the square root in the denominator. Okay, so which method we use to accomplish it? Well, our first case, if we can simplify it so that we can cancel some things off, we really don't have to rationalize much. But on case 2 and case 3, where we just had like a single term, or we had like multiple terms with the square root, that's when we actually had to rationalize and multiply kind of by whatever the bottom is or by the conjugate. So go ahead and jot something down and go ahead and get started on your practice problems.